Hey guys, so today we want to discuss the question called as count nodes equal to average of subtree. So this is a Leetcode medium question, and I wouldn't say this is an important question like that. The reason why I have choose this question is the approach which we are going to use is used in many tree questions. Like it's some kind of an optimized approach for many tree questions. So that's the reason why I thought of taking up this question. So let's start reading the question. So given the root of binary tree, return the number of nodes where the value of the node is equal to average of the values in its subtree. So first thing, what they're trying to say is they'll be giving a binary tree, right? So you have to find the number of nodes where its value is equal to average of its subtree. First thing, we have to know what is an average, right? So let's try to know what is an average. For example, let's say we have some elements like 1, 2, 3, 4 and 5. So these are the elements. So here n is 5. N is the number of elements in this collection. So n is 5, right? So now let's try to find the sum of this. So it's going to be 1 plus 2 plus 3 plus 4. So the sum is going to be 15, right? So this is sum. So now average is nothing but the sum divided by number of elements. That's it. So in this case the sum is 15. So the number of elements are 5. So the average is going to be 3. So this is the average of the given these elements. So this is how you find, if you have the number of elements or the collection of elements, this is how you find the average of those elements, right? So now let's try to take in terms of a tree. For example, let's take, we are having this kind of a tree where it looks like this, right? So now let's try to find out average of every subtree. So starting with 4, so its value is 4, right? So value is equal to 4. So now we have to find the average and we have to make sure this average and value should be same. So now let's try to find the average of this subtree. So we are having 4, right? So 4, and next one is 8 and 5 plus 0 plus 1 and 6, right? So now let's try to sum it. So it's going to be 7 plus 5, 12 plus 8, 20, and it's going to be 24, right? So 24. So 24 divided by, it's a sum. So let's try to find number of elements in it. So it's 3 plus 3, 6. So it's 4. 6 1 6 4s, right? 6 4 24. So now the average is going to be 4. So average is 4. So we have got a case where value is equal to average. So we can just say this is a node where its average is equal to its value. So what we can do is, maybe you can use an answer variable and initially it is 0. Now as we have got a case, right, so we can just increment it to 1. So now similarly we can find out for each and every node. All we have to do is just keep track of the current node and just do the sum of its subtree and find the average and just see whether its average is equal to the current node or not. So that's how we do this. That's how we do for all the nodes. So let's try to find out how can we optimize this. I mean, we are starting from each node and trying to go to the subtree, right? So how can we try to optimize this? Let's try to see some same example and let's try to see how can we do that. So previously we have started from the top, right? We have started from the top of the tree and we have went downwards, and for each node we have again done the the 2 times again we are going downwards. I mean, we're just doing some repetition process again and again. So that's something like, as you're doing 2 times, like for each node we are trying to do traverse the entire tree, right? So that's going to be like almost order of n square time complexity, right? So now we have to optimize that. Let's try to optimize that. So how can we optimize that? So what we can do is, instead of starting from the top of it, because when you're trying to starting from top of the tree, by the end of the day we are just coming from the bottom. We're going to bottom, right? So what if I can just start from the bottom and keep track of the sum of the nodes? So for example, let's say I have come, let's try to do post order. So post order is the best way in the situations whenever you want to do something from the bottom. So post order would be the best option. So which is post order. So for post order, the order would be left, right and root. This is how you conquer the nodes using post order, right? So now let's try to do post order. Initially you'll be here, right? You'll be at 4th node, which would be here. So you'll come towards left. So first you have to acquire left. So come, you'll go again left, again you'll go left. So as there is no left for the 0, you'll come back, right? So now we'll go again right, it doesn't have anything, you come back to 0. So now you have the left and right values, because there are no values towards the left, so it's going to be, we're going to return 0 from left. So there are no values towards the right, we're going to return 0 from the right. That actually means the left subtree of this 0 doesn't have any elements, the right subtree doesn't have any elements. So what we have to find, how can we find the total number of nodes in this subtree, which is going to be the left nodes plus the right nodes plus 1. Why this plus 1? Because we have the current node, right? So the left one will only send the left subtree values, the right one will only send the right subtree number of nodes. So now to get the current node, we have to add plus 1. So now in this case the sum would be just 1, because 0 plus 0 plus 1, so it's going to be 1. So let's find the average. So sum is 1, we have to divide it by number of nodes. In this case it's 1, so average is 1, right? So average is, this 1 is not equal to 0, so we don't have to increment our answer. Let's try to use an answer variable, so we don't have to increment the answer. So let's go back to our postular traversal again. So again from 0 we are returning the left and right plus 1, so it's going to be 2, I mean 1, yeah, it's going to be 1, because left subtree has 1. So now we are going towards right. Again the same thing, the left doesn't have anything, which returns 0, the right doesn't have anything, which actually means 0. So now 0 plus 1, right? So it's going to be 1. So now the sum is 1, let's try to divide by number of nodes, which is 1, which is average would be 1, right? So average, which is 1, and the value is 1. That actually means they are matching. So let's try to increment to 1. That actually means there is a node which is equal to the average of each subtree. So now again let's move on with our postular traversal. So now I'll come back, I'll be sending this 1 to the top. So now it actually means towards the left subtree of 8 there are 1 nodes, towards the right subtree there is only 1 node. So now how to find the number of nodes in the subtree, which actually means left plus right plus 1, right? So left has 1 and right has 1, and the current node would be 1, so it's going to be 3. So these are the number of nodes in the subtree. So what we can do is not just sending the number of nodes to left and right subtree, we also have to send the sum of the left and right subtrees. So in this case the sum would also be 1. In this case the sum would also be 1. In this case the sum would be 0, I mean sorry, because the left subtree sum is just 0, right? Its value is 0. In this case the right subtree value is just 1. So now we have to find the sum of the current one. So what I can do is, let's try to find the sum. The sum would be the left sum, the right sum plus the current node value. So it's going to be 0 plus 1 plus 8, which is 9, right? This is the sum. So now let's find the number of values. The number of values would be the left values, then the right values plus 1. So it's going to be 1 plus 1 plus 1. It's going to be 3, right? So now this is the sum, this is the number of nodes. Let's divide this both. So it's going to be 3. So average is 3, right? So now 3 is not equal to 8, right? So that actually means it's not matching. So let's try to continue with the post order. So what are we going to send towards the top? The number of nodes, of course, which is 3, and the sum of the subtree. So it is going to be 9, right? So 9. How are we sending 9? The left sum, right sum plus current node. The left sum is 0, the right sum is 1, the current node is 8. 0 plus 8 plus 1, it's going to be 9. That's how we are sending. So now as we have done with the left subtree of 4, we have to go to the right. So we have to find the right sum and the number of nodes towards its right. So we'll be going to 5. So we're going towards left from 5. So 5, the left side of 5 doesn't have any elements. We'll be sending 0 towards the 5. We'll come to 6 again from here. So 6 doesn't have any left. We'll be sending 0 towards up, again here 0. So now the left has 0 elements and 0 sum, the right has 0 elements and 0 sum. That actually means the n would be, in this case it's just 1, so sum would be just 6. So now what is the average? 6 by 1, which is 6, right? That actually means it satisfies, right? It satisfies. So now 6 plus 6 is equal to 6. That actually means we have to increment it to 2. So now let's try to return the values and its sum, the number of nodes and sum. So the number of nodes is just 1, the sum is 6. So we have the left and right. So here left is just 0, 0, 0 number of nodes and 0 number of 0 sum. The right is 1 node and 6 sum. So now the sum in this case would be 5 plus 6, and which is going to be 11. The number of nodes is going to be 2, right? So 11 by 2, which is just 5. Average is 5. So now 5 is matching. 5 is matching with this. So that actually means we have to increment it to 3. So now let's try to find the average of the 4. So now we have got to know the left has 0, the right has sum 6. So the next sum we have, which we are going to send, is going to be in this case it's going to be the left right side 6 plus 5. So it's going to be 11. It has 2 nodes towards the right and 11 as sum. So now again let's find out the number of nodes in its subtree at the root at 4. So the number of nodes would be the left has 3 nodes, right has 2 nodes, and plus 1 for the current node, which is going to be 6. Let's find the sum. The left has the sum of 9, the right has the sum of 11 plus the current node, which is 4. So 15 plus 9 is going to be 24, right? So 24 by 6, which is going to be 4. So the average is 4, right? So 4 is equal to current node, which is 4. So let's increment the value to 4. So as we're done with the entire tree, so by the end of the time, the answer which we have got is 4. That actually means there are 4 nodes where its value is equal to average of its subtree. So see, we have done with single traversal itself. We didn't do any multiple traversal for each and every node. So in this case, the time would be order of n, because we have just done one traversal only, right? It's just going to be order of n time complexity. So this is the approach which is used for many optimized tree questions, because we have optimized the pre-order traversal to the post-order traversal, right? So that's why this is preferred for many questions actually. So whenever you want to do something from the bottom, you prefer post-order traversal. So let's try to do it. Let's try to implement this. Let's try to code this. So here we are having a method called as average of subtree, where it passes the root of the tree, where we have to return the number of nodes whose values are equal to average of its subtree. So first things first, what I'm going to do is I'm going to create a variable just to keep track of the answer. So the default value is anyhow 0, right? I'm going to leave it as it is. So now I'm going to create an extra method. So it's, let's name, maybe it would be like find. So where I will be passing the root of the tree, which is of type tree node. So now what we have to do is, as you have seen in the before explanation, right, we have to send the number of nodes in that subtree and the number of the sum of the nodes in the subtree. So for that, what I'll be doing is I'll be creating a data structure. Let's name it as node maybe. So it would look like this, and which contains sum, it contains n. I'll create a constructor quickly. So it's going to be int n. So this dot sum is going to be sum, this dot n is going to be n, right? So this is it. So now let's try to implement this find method. So the return type of this would be node, where I'll be returning the number of nodes in a subtree along with the sum of the nodes. So initially in this leaf cases, if you have gone towards left, that actually means it is null, right? So if it is null, the number of nodes are 0 and sum is also 0. So if root is equal to null, just return a node where it represents 0 sum and 0 nodes. You got it? Okay. So now if it is not null, then we have to go towards left. So we have to go towards left, find root dot left. When we have done with the left subtree, this method call is going to return us the number of nodes towards left subtree and the sum of the left subtree, and we'll be storing it in this left reference variable. Similarly towards right, node right, find root dot right, and this is going to return us the number of nodes towards right subtree and the sum of nodes which is towards right of this current node. So now let's try to find the sum of the entire subtree. Int sum. So how can we find the entire sum of the subtree? which is nothing but the sum of the left subtree, the sum of the right subtree plus the current one, which is 1, right? Which is going to be left dot sum plus right dot sum plus 1. This is it, right? I mean, it's going to be root dot value. I mean, we have to find sum of left subtree, sum of the right subtree plus the current root value, which is going to be root dot value. So let's find the number of nodes in this subtree. Let's take it as n. So it's going to be left subtree nodes, number of left subtree nodes, the number of right subtree nodes plus 1, which is the current one. So now we have got the sum and number of nodes. So if you got the board, it's very easy to calculate the average, right? So it's going to be average sum by n. This is it. So now we have to just see if average is equal to root dot value, just increment, we have found a node, answer plus plus, and we have, after incrementing, what we have to do, we have to send the current subtree sum along with the number of nodes in the current subtree, or it's going to be just return new node with the current sum and the number of nodes in the current subtree. So we have to call this function, right, initially. So it's going to be find root and we have to return answer at the end. So it's going to be answer, sorry. So this is pretty much the implementation of it. So we have basically done postal or traversal. That's it. We have took the left and right values and just done some evaluations and just done some operation. That's it. So let's try to run this. Yeah, it worked. Let's try to use some extra test cases. Yeah, let's try to submit this. Yeah, it's got succeeded. So this is how you find the count nodes equal to average of a subtree. So basically all we have done is just a post order traversal. We have basically optimized the in order or pre-order traversal to a post order traversal. We have started from the bottom and done a lot of optimization. So if you like the video, please make sure you like and subscribe. Thank you.